Hey everyone, Geek37 back with another video. This is part 7 in my Exploring the Heptagonal Triangle series. And what we're going to do today is we are going to look at the sine ratios in the heptagonal triangle in a bit of a different way than I showed yesterday. Now what I'm outlining here in orange is the top isosceles triangle in the regular heptagon. We need the regular heptagon to show where these new sine ratios are going to come from. I have marked out A, and the whole diagonal here, since we're skipping one vertex, as B. We will drop the altitude down. Let's call this H sub A for the height of that A-type triangle. And the distance, we'll call this point in the middle here M, and the distance from FM will be B over 2. So let's set up the Pythagorean theorem. H sub A quantity squared plus B over 2 quantity squared equals A squared. And the reason we're doing that is because we have a right triangle formed with that altitude. So solving out for H sub A squared, we'll get A squared minus B over 2 squared. So H sub A squared is equal to A squared minus B squared over 4. Doing some more algebra, we'll notice that the common denominator is going to be, this here should be over 1. So 1 times 4 is 4, so it's 4A squared minus B squared over 4. We'll take the square root to both sides, so H sub A will equal the square root of 4A squared minus B squared. And since we will include the 4 underneath there, I'm not going to show it, but the square root of 4 is 2. Now, what we need to do is we need to set up a ratio. The angle inside here was pi over 7. So the sine of pi over 7 will equal H sub A over A. So what we'll get is 4A squared minus B squared all over 2A, just like that, and that is the first one. And the reason we are setting it up this way is because we are going to use these radical ratio identities to prove a very complicated calculation that will be needed for subsequent videos in the series. And I intend to do that calculation in this very next video. Okay, so now in the next part of this video, what we're going to do is we're going to skip every other vertex here. And now we have B, and C. So what will happen is we'll drop the dropping the altitude down. We'll call this H sub B. And what will happen is, again, let's use just the letter, let's do N this time. So we have this length here of C. Let's erase this little c here. And of course, the distance from N to G over here will be C over 2. So again, we'll set up the Pythagorean theorem. So we will get H sub B quantity squared plus C over 2 quantity squared equals B squared. So we'll solve for H sub B squared equals B squared minus C squared over 4. So H sub B squared will equal 4B squared minus C squared over 4. We'll take the square root to both sides. 4B squared minus C squared all over 2. So that means the sine of 2 pi over 7. And the reason why this, and we showed this yesterday, this is 2 pi over 7. The angle up top here was 3 pi over 7 because the angles here were pi over 7 and pi over 7. So what happens is the sine is going to be H sub B over B. The H sub B is opposite 2 pi over 7. The hypotenuse is B. So we will set up the ratio as 4B squared minus C squared all over 2B. And that's the second one that we need for the calculation that I intend to complete in my next video. All right, everyone, and the last one that I want to do is we're going to connect E to A and E to B, and of course A to B, like so here. And then what we'll do is we'll write this as C because we're skipping two vertices, C and A, and of course we'll drop down the altitude. We'll call this H sub C. Now, if you remember yesterday, we showed that this was pi over 7, and then the angles down here were 3 pi over 7 in each corner. So what we'll wind up doing is we'll figure out that the sine of 3 pi over 7 is going to be H sub C over C. And as you can see here, let's call this point P in the middle, and then we will do this as A over 2. So then, of course, with the Pythagorean theorem, H sub C squared plus A over 2 squared equals C squared. So then we will solve for H sub C squared, which equals C squared minus A squared over 4. So H sub C quantity squared will be 4 C squared minus A squared over 4. Take the square root to both sides. H sub C will be 4 C squared minus A squared all over 2. So the sine of that will be 4C squared minus A squared all over 2C. But if you also remember, because of the way that the sine ratio is between 0 and pi radians, the sine of 3 pi over 7 is equal to the sine of pi minus 3 pi over 7, which is equal to the sine of 4 pi over 7. So then the sine of 4 pi over 7 also has that ratio of 4C squared minus A squared all over 2C. And that concludes this lesson for right now. So once again, I'm going to use these three ratios that I found to prove a difficult calculation in the next video, and then we will use the result of that calculation to do some more proving of identities down the line. All right, I hope you enjoyed this video. I enjoyed making it. This is Geek37 signing off.